The alternate form of the definition of a derivative allows us to find the derivative of a function at a specific point. In this particular case, that point is going to be where x is equal to a. So this formula that we have here allows us to find the derivative of f at x equals a. Another way to say that is to find f prime of a, which is what we have there in the beginning. Okay, so f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. Alright, so for an example, we're going to use the definition of the derivative to find f prime of 3. So what this is asking us to do, it's asking us to find the derivative of f at x equals 3. And so in order to do that, we're going to use the formula that we have up there, which means that I have to take the limit as x approaches a. And by the way, let's go in and write what that is. That's f prime of 3 is equal to the limit as x approaches a. Let's put a 3 here since we know that a is equal to 3. So the limit as x approaches 3 of f of x, well, what is f of x? F of x is just the original function, but it's going to be f of x minus f of 3 over x minus 3. Well, this is equal to the limit as x approaches 3 of, we're going to put all of f of x here, which is negative 2x squared plus 3x plus 1. I'm sorry, it's going to be minus 1. Okay. Minus f of a, which is going to be the same as f of 3. So f of 3, we know how to find f of 3. I'm going to put it right here in the corner here. F of 3 is equal to negative 2 times 3 squared plus 3 times 3 minus 1. That gives us a negative, that's 3 squared is 9. So 2 times 9 is going to give me a negative 18. Plus 3 times 3, which is 9, minus 1. Negative 18 plus 9 gives us a minus 9 minus 1. That gives us a negative 10. So that is our f of 3, which is going to go right here. All of that over x minus 3. Alright, well, this is equal to the limit as x approaches 3 of, I end up with a negative 2x squared plus 3x minus 1 plus 10 all over x minus 3, and numerator, that's negative 2x squared plus 3x plus 9 over x minus 3. If you were to use direct substitution, you'll find that this gives you 0 over 0, which means that we're going to have to factor the numerator, and hopefully some factors will cancel. So let's see what happens. So this gives us the limit as x approaches 3. So the first thing I'm going to do is factor out a negative 1, and then I'm left with 2x squared minus 3x minus 9 all over x minus 3. And then I have a negative on the outside, that negative 1. I can go on and factor the inside, which is going to give me a 2x here and an x there. I'm trying to find factors of 9 so that when I combine them, I can get that negative 3x in the middle. When I combine my outer terms and my inner terms, let's see. If I put a 3 here and a 3 here, and maybe put a negative here and a plus there, if I multiply that back out, I get 2x squared minus 6x plus 3x. That minus 6 plus 3 is going to give me a negative 3x in the middle. Notice my x minus 3's cancel, and I'm left with the limit as x approaches 3 of negative 2x plus 3. Now I can use my direct substitution, which means I could just plug in my 3. That's going to be negative 2 times 3 plus 3. That gives me a negative 6 plus 3, which gives me a negative 9 as my answer.